right, we're talking about transformations. This is chapter 7. This is section 1. The first thing you need to know is what a transformation is. And we did some practice of different types of these in class. But now in your notes, you need to get some of these definitions and examples written down. So a transformation is just moving all of the points of a geometric figure to create a new image. You're shifting it or reflecting it or rotating it, and we'll talk more specifically about what those different transformations look like. You also need to know how we represent that. If you have a point and you call that point A, that was your original point, once you transform it, once it's moved on the new image, it's called A prime and has that little apostrophe looking thing there. Okay, and remember that's called prime is how you would say it. So A prime. And that would be the case for any point. So if it was C, it would be C prime. Okay, if your image, once it's transformed, is congruent to the original one, that means it's kept its same size and shape, it's just in a new location, that's called a rigid transformation or an isometry. Okay, if the size or shape changes, okay, this is a non-rigid transformation. And we're not going to really be dealing with many of those until later in the year. Right now we're going to be focusing on isometries. Okay, the 3 types of isometries we're going to deal with that we practiced today to get us started were translations, rotations, and reflections. And I've put a few examples here for you to see. If you want to just draw some of these out, you can. You have your original picture. It is just shifted or moved. Okay, that's a translation. You can do this using patty paper. You would trace the original figure, move the patty paper over, and that would be a translation. Okay, you can also do this on the coordinate grid. Notice we have triangle ABC, and then we have triangle A prime, B prime, C prime. Okay, those points were all just shifted over, but they were shifted over the same number, the same distance and direction, okay, that it kept its shape and size, so that's still an isometry. Okay, rotations. This is your point of rotation, and you rotate your figure about this point. Okay, so this brightest blue is rotated to where it's now pointed in this direction. Okay, here's just another example showing you here's the center of rotation, and you rotated this whole figure. Okay, and then a reflection, you're going to have some sort of line of symmetry that you're reflecting it over. Here it's just a vertical line. Okay, here we have a slanted line, and it's using patty paper showing you if you have an image and you fold it and trace that image, okay, that fold is the line of reflection or the line of symmetry, and you just mirror that image over. Okay, you could also do this here if it's on a grid and these end up meeting up, you end up creating a figure, like you can finish out. That's what we did today with that bugs, bugs, bugs reflection. Section 7.2 talks about the different properties of isometries. Okay, we're going to have what are called ordered pair rules, and you saw one of those on the activity today that was called falling down. You have your original XY point on your grid, and it's shifted over X plus H and or Y plus K. Okay, that H, that number that's added or subtracted to your X, that's a horizontal shift. That's left and right, just like the X-axis. Okay, the K is added or subtracted to the Y, and that's a vertical up or down shift, however many units K is. Okay, if you want to draw this example in your notes, you can draw this figure on the coordinate grid, and they want us to transform it using the rule x plus 2, y minus 3. That means to all of my points, whatever the x value is, I'm going to add 2, and the y value I'm going to subtract 3. So that is shifted 2 to the right and 3 down. So 2 to the right and 3 down. Okay, and you would do that to each of your points. Okay, and this image over here shows that translation. Okay, so over to the right 2 and down 3. There are some specific conjectures that we can write that are always going to be true. They're the coordinate transformation conjectures. And the first ordered pair rule says that if you go from xy to negative xy, so you just change the sign of the x only, okay, this is a reflection over the y-axis. Okay, so this is an image that's reflected across that y-axis. So that's like if you fold your paper hot dog style. Okay, the ordered pair that was xy that becomes x negative y, so you only change the sign of y. This is also a reflection, but now this is over the x-axis. Okay, so you would fold your paper hamburger style. You'll fold it down over that x-axis. And then if your ordered pair changes both of the signs, it goes from xy to negative x, negative y, this is actually a rotation about the origin. That means you're using your origin as the center of rotation. Okay, and then the ordered pair that goes from xy to yx, you switch the order. Okay, this is a reflection over the line y equals x. Okay, if you need a visual of that, if you have your xy axis, the line y equals x is this line that goes through the origin with a slope of 1. So if you had an image over here, it would reflect over here if you just switched the x and the y. And really we should add here to this rule the rotation about the origin. This is a 180-degree rotation for that rule. Okay? Alright, then there's compositions of transformations. This just means we're combining more than one. Okay, so this example here says that you're to draw ABC. Okay, here's the original ABC. I'll highlight that in green. So we have triangle ABC on the coordinate grid. Okay, they want us to relocate its vertices, okay, those points A, B, and C, with the rule to get A prime, B prime, C prime. Okay, so here's A prime, B prime, C prime. Okay, use the rule x minus 6, y minus 5. That means shifted to the left 6, because whatever is with the x, that's horizontal, and negative means to the left. And what's with the y is vertical, and this is negative, so it means down 5. So point C was left 6 and down 5, and that got me to C prime. Okay, and then they did the second translation, which was x plus 8, y minus 2. I'm sorry, that was from here. So we're coming from A prime to A double prime. So from this new image, our first translation, we're going to follow the rule x plus 14, y plus 3. Okay, so this is horizontal and it's positive, so that means it's to the right 14 and up 3. Okay, so C is then to the right 14 and up 3. So C initially went here and then here. If we combine this into one, okay, a composition of these two movements, okay, we can go a straight shot rather than doing this zigzag here. Okay, and you just combined the two transformations. The first one for the x was -6. The second one was +14. If you combine the -6 and the +14, okay, that gives you +8. Okay, so you can do one movement instead of two. You can do the same thing with the y movements. It was -5 and then +3. -5 and +3 is -2. So you're combining more than one transformation to create a single transformation. Okay, and notice they wrote this in parentheses here. They said the original movement from 2,6 directly to 10,4. Those are the coordinates, the xy coordinates. Okay, and then down here at the bottom you can see that it says each vertex is moved left 6, right 14, down 5, up 3. So that's what I just highlighted for you, was combining those. Okay, so here was the -5 and 3 went to -2, and the -6 and 14 went to +8. This can also be written as 8, -2, because this was a +8 and a -2 movement. So your transformation, or your composition of transformations, can be written this way. Okay, you can also have compositions of transformations that aren't two translations, not two slides. You could have a slide and then a rotation, or a slide and then a reflection. So you just have to do your order in which they tell you to do your transformations to get your final image. Okay, but when it is two translations and you can add or subtract your numbers, okay, that's the composition of transformations. Okay, so that's pretty much what you need to know. Make sure you bring these notes to class.